Hello, and welcome to Backer Breaks It Down. In this episode, we're going to take a look at properties of segments and angles. If AB is congruent to CD, does AC have to be congruent to BD? Well, we can see that AB is 7 centimeters long. We can see that CD is also 7 centimeters long. After all, they are congruent. So, what about segment AC? Is it congruent to BD? Well, if you're like, they're both 10 centimeters long, good. So that means they're congruent, right? And you added that 3 centimeter segment to both the 7 centimeter segment to get 10. So you added the same segment to a pair of congruent segments, and you got congruent segments. Okay. Let's take a look at the next diagram. Is angle EFH congruent to angle JFG? Well, let's examine these angles. So here we have angle EFH. It's made up of that 50-degree angle and this guy, angle JFH. Okay, so what about the other angle, JFG? It's made up of a 50-degree angle and, once again, JFH. So are they congruent? Yeah, I think so too, because you're just adding angle JFH to two congruent angles. So they're congruent. Okay. Is segment KM congruent to segment PO? Well, take a look at KM. It's made up of two smaller segments. You've got KR, which just so happens to be congruent to SO, and you have RM, which is congruent to PS. So would that make KM congruent to PO? Yeah, like we just took congruent segments and added them to congruent segments, and what did we get? Congruent segments. Is angle TWX congruent to angle TXW? You're seeing what I'm seeing? That those two angles are made up of two pairs of congruent angles added together? So I guess they are congruent. All right, let's see if I can stump you. If AC is congruent to BD, does AB have to be congruent to CD? Well, let's take a look at these segments because they're overlapping. So here we have segment AC, and here we have segment BD. They overlap at BC. That's their intersection. So does that mean the blue segment and the yellow segment are congruent? Yeah, you just subtracted the same segment from a pair of congruent segments. And then our last one. If angle STE is congruent to angle WET, so let's look at that first. So here's STE and here's WET. They're congruent. And we know that angle STW is congruent to angle WES. So does that mean that angle SET is congruent to angle WTE? So would these two angles be congruent? Yeah, like all we did was subtract congruent angles minus congruent angles equal congruent angles. So these all illustrated these properties. Okay. You've got the segment addition property, the angle addition property, the segment subtraction property, and the angle subtraction property. So if you add congruent segments plus the same segment, you get congruent segments. If you add congruent angles plus congruent angles, you get congruent angles. If you take congruent segments and subtract congruent segments, you're going to get congruent segments. And that's what these properties are saying. Now notice there's like if a segment is added, if an angle is added, if a segment is subtracted, if an angle is subtracted. When you find yourself doing that, then your proofs are going to feature something called the reflexive property. The reflexive properties basically says that any segment or angle is congruent to itself. So before I get to a proof, let's do some addition and subtraction. So name the angles or segments that are congruent by the addition property. So we can see in problem 1a that EA is congruent to BA. They both have identical tick marks. That's how I know. And we can see that DE is congruent to CB. So if you do some segment addition, what's going to be congruent? You're right. DA is going to be congruent to CA because congruent segments plus congruent segments equal, you got it, congruent segments. So let's take a look at some angles. I can see that this angle JFH is congruent to this angle FHG. And I can see that angle HFG is congruent to JHF. So if you take the yellow angle and add the green angle, what do you get? Well, you're going to get that angle JFG is congruent to angle J, that's angle JHG. All right, what about some subtraction? In 2a, you can see that our T is congruent to SV. So if you do some subtracting of that ST in the middle, what two segments are going to be congruent? That's right. RS is going to be congruent to TV. In problem 2b, we can see that the big angle WXZ, given by the double arc mark, is congruent to angle ABD. We can also see that this angle right here, WXY, is congruent to this angle here, ABC. So using some angle subtraction, what can you prove to be congruent? That's right. You can prove that angle YXZ is congruent to angle CBD. Are you ready for a proof? Well, too bad. We're going to do one anyways. All right. We are given that segment. Let me get my highlighters ready. That segment GJ is congruent to segment HK. Do you see what I see? Yeah, I see that they're overlapping and that they have HJ in common. I'm also seeing that if you do some subtraction, you get that GH is congruent to JK. So what does our proof look like? Well, got to start with the given information. Now, since I'm subtracting HJ, I need to introduce that to my proof. I can say that HJ is congruent to HJ. This is that reflexive property. So now if I do some subtraction, if I go GJ minus HJ, I'm going to get that segment GH. And if I go HK minus HJ, I'm going to get this segment JK. And that's what I'm trying to prove is congruent. So I did some subtraction with segments. That's the property that I used. Segment subtraction property is my reason. So one more problem, I guess 2 more problems before we go. Okay, let's see if you can do these before I tell you what the answer is. Pause the video, give it a shot. So we're given that angle TNR is congruent to TRN. We also know that angle NRS is congruent to RNS. So what can we prove to be congruent? You're right. Angle TNS can be proven to be congruent by angle to angle TRS by that angle subtraction property. What did you say about problem B? You're given that AB is congruent to CD. What segments can be proven congruent? Well, if you said AC can be proven to be congruent to BD by the segment addition property, you would be correct. Congratulations. And so that's how you use the addition and subtraction properties in proofs. And that's how Becker breaks it down.